You've never been to heaven, have you?
Assalamualaikum warahmatullahi wabarakatuh. Hi there.
Hello everyone.
Hello everyone!
Back again with Heaven Group. So in this video, we are going to explain about matrix. But before we start, let us start with introducing ourselves. My name is Andi Putri Ahira.
My name is Audriana Septiani.
My name is Dayana Anissa Putri
My name is Denzel Sudjono from the Heaven Group.
From Heaven Group.
From Heaven Group.
from Heaven Group, International Management Class, Faculty of Economics and Business Untan. I will explain about the concept of matrix and how to adding and subtracting the matrix.
In this time, I will explain about matrix multiplication and matrix transpose and the practice question.
In this video, I'm in charge of explaining the determinant of a matrix and Kramer's rule.
And here I'm in charge to explain about inverse matrix and also practice questions.
In mathematics, a matrix is also known as matrices. It is a rectangular array of numbers, figures, or expressions organized in rows and columns. Matrices are one of the most powerful tools in mathematics. The evolution of the concept of matrix is the result of an attempt to obtain compact and simple methods of solving the system of linear equation. A matrix having m rows and n columns is called a matrix of order m by n or simply m by n matrix. There are 5 types of matrix, such as row matrix, column matrix, square matrix, rectangular matrix, and diagonal matrix. On this lesson, I will introduce the first 2 out of 4 basic operations that can be done with a pair or more matrix: addition, subtraction, scalar multiplication, and multiplication. We know this basic operation from arithmetic, and so we just need to learn how they work with the whole structure of the matrix and the result they produce. We start by working through the 2 most basic operations we have known since we first were introduced to mathematics in elementary school: addition and subtraction, or plus and minus. We can only add or subtract matrices if their dimensions are the same. To add matrix, we simply add the corresponding matrix elements together, and to subtract matrix, we simply subtract the corresponding matrix elements together. And we're going to rules on adding and subtracting matrix with the same size or dimension. Suppose matrix A and B both have 2 rows and 2 columns, with some arbitrary elements or entries. First, add matrix by adding their corresponding entries. A formula showing how to add matrix A and B, that is matrix A plus matrix B. Second, subtract matrix by subtracting their corresponding entries. A formula showing how to subtract matrix A and B, that is matrix A minus matrix B. So we're going to the examples for adding matrix. The matrix A and C have the same size or dimension because the numbers of rows and columns are the same. Both can be described as 3 by 3 matrix. From my previous explanation, we know that the formula is to add matrix by adding their corresponding entries, so we can get the result. For examples number 2, subtracting matrix. To solve this problem, use the same method as the previous question. The formula is to subtract matrix by subtracting their corresponding entries of F and D, so we can get the result.
Matrix multiplication is a matrix that involves 1 or 2 matrix or array of numbers in the form of columns and numbers and has certain characteristics. Matrix multiplication, also known as matrix product.
Next, there are 3 types of matrix multiplication. The first is matrix multiplication by scalar. Second is 2 by 2 matrix multiplication. And the last is 3 by 3 matrix multiplication.
First, matrix multiplication by scalar. Matrix multiplication by scalar is multiplication of an integer with a matrix. For the example, multiply the matrix A 6, 3, 4, 8, minus 2, and 5 by 4. So A is 6, 3, 4, 8, minus 2, and 5. Now we have to multiply each element of the matrix A by 4. The form is 4 times A. So it is 4 times 6, 3, 4, 8, minus 2, and 5. The result after multiplying the given matrix by the constant is 4 is 24, 12, 16, 36, minus 8, and 20. Next, 2 by 2 matrix multiplication. The formula is if A times B. So the formula is A times B equal to open bracket AJ plus BL, CG plus DL, AK plus DM, CK plus DM. For the example question, A equal to matrix 2, 9, 6, 4, and matrix B consists of minus 2, 5, 4, and minus 7. And the result is matrix 26, 2, minus 34, and 8. Third, 3 by 3 matrix multiplication. For the example question, now matrix A equal to matrix 0, minus 1, 3. Next, 3, 2, 4, and then 1, 0, and 2. For the matrix B, it is 2, 0, 3, 1, 0, 3, 1, 4, minus 1. Divide the result of AB. The way to solve this question are get the first row by multiple the first row A with the 3 column of B. The second row we get from multiple the second row of A with the 3 column of B, and last we get the third row by multiple the third row of A with 3 column of B, and the result is matrix 3 minus 2, 12, next 3 minus 1, 9, and then 11, 7, and 17. Next, matrix transpose. Matrix transpose is simply a flipped version of the original matrix. We can transpose a matrix by switching the rows with the column and the columns with the row. We denote the transpose of matrix A by A power T. For the example, matrix A is matrix 15, 7, and then 9 and 0. Define the A power T. So it's transposed to be matrix 15, 9, 7, and 0. For this question, the form doesn't change. The form is still same. It is 2 by 2 matrix. Second question, matrix B is 5, 4, 12, 8, 17, and 20. Define the transpose matrix for B. From the question, we need to switch the number from row to be column and from column to be row. So the result is 5, 12, 17, and 4, 8, and 20. This question changed the form of this matrix from 2 by 3 order into 3 by 2 order.
The determinant of a matrix is the scalar value or number calculated using the square matrix. The square matrix could be 2 by 2, 3 by 3, 4 by 4, or any type, such as n by n, where the number of rows and columns are equal. For example, 2 by 2 matrix means there are 2 rows and 2 columns inside the matrix. The determinant of a matrix is represented by 2 vertical lines, or simply by writing det and writing the matrix name. For example, det A or det open bracket A, or A between 2 vertical lines. It is the same symbol as absolute value, but it do not mean absolute value. Now, how do we calculate the determinant? Starting with the 2 by 2 matrix, which we can write as A equals to matrix of A, B, C, D. The determinant for it is the determinant of A equals to A times D negative B times C. How do we find the AD negative BC? Well, it's easier to remember when you think of a cross inside of the square matrix. So A is lined with D and B is lined with C. So the determinant of A is A times D and negative B times C. It is simply calculated by cross multiplying the component from top left to bottom right and then finding the difference of those two.
Okay, so in here we need to find the determinant of C equals to 4, 3, and 6, 8. Remember, it's easier to remember of a cross when you want to solve a 2 by 2 matrix. So if you think of a cross inside the square matrix, 4 is lined up with 8 and 6 is lined up with 3. That makes it 4 times 8 minus 6 times 3. So the determinant of C equals to 4 times 8 minus 6 times 3 equals to 32 minus 18 equals to 14. So the determinant of C equals to 14.
In order to find 3 by 3 matrices, we need to understand the term of minor of an element. Minor of an element is the determinant of a square matrix of any order derived by deleting the row and column containing the element. Now, a 3 by 3 matrix is which we can write as A equals to matrix of A, B, C, D, E, F, G, H, I. So the determinant is the determinant of A equals to A times in the bracket of E times I negative F times H minus B times in the bracket of D times I negative F times G plus C times in the bracket of D times H negative E times G. It may seem complicated, but there is a pattern for that. It may be easier for you to understand. To work out the determinant of 3 by 3 matrices, multiply A by the determinant of a 2 by 2 matrix that is not in A's row or column. Remember the term of minor of an element. If we want to look in the element of A, we should derive by deleting all the element in A rows and columns. So for the A rows, the determinant for it is E, F, and H, I. Likewise for B and C. Then sum them up, but remember the minus in front of the B. As a formula, the determinant of A equals to A times E, F, and H, I minus B times D, F, G, I plus C times D, E, G, H. The pattern continues for 4 by 4 matrices or higher. This is the formula of a 4 by 4 matrices. Notice the pattern of plus, minus, plus, minus.
So now, here's the example of 3 by 3 matrix. So the matrix is given by A equals to 4, 1, negative 1, negative 3, 0, 5, 5, 3, 2. Find the determinant of A. So the determinant of A equals to 4. Now, our focus first is 4. Remember, if you want to look for an element, you have to eliminate all the numbers in that element's row or column. So if we want to look for 4, we need to eliminate all the numbers in 4 rows, which will be left with 0, 5, and 3, 2. The square matrix of 0, 5, and 3, 2. Minus 2, negative 3. So minus 2, negative 3, so which will be getting rid of all the numbers in the negative 3 rows and column, which will be left with 1, negative 1, and 3, 2 inside the square matrix. And then plus 5, so our focus here is 5. We need to eliminate all the numbers in 5's row or column, which will be left with 1, -1, 0, 5 into the 2 by 2 square matrix. After that, so 4 times 0 times 2 minus 3 times 5 minus to -3, which will make it +3 because minus meant minus. 1 times 2 minus to 3 times -1. So +5, 1 times 5 minus to 0 times -1. So the determinant of A equals to 4 times 0 times 2 minus to 3 times 5 plus, because minus meant minus, it would be +3 times 1 times 2 minus to -1 times 3 plus 5 times 1 times 5 -0 times -1 equals to 4 times 0 minus 15 plus 3 times 2 plus 3 plus 5 times 5 minus 0, which makes the determinant of A equals to -20.
Kramer's rule is one of the important methods applied to solve a system of equations. In this method, the value of the variables in the system are to be calculated using the determinant of a matrices. Thus, Kramer's rule is also known as the determinant method. Let us consider a system of equation in n variables of x1, x2, x3, and so on, written in a matrix form of ax equals to b, where A is the coefficient of a matrix, which is a square matrix, X is the column with variables, and B is the column with constant, which are on the right side of the equations. To solve the system of AX equals to B, first we need to find the determinant of A and represented by D. And then we need to find the determinant of dx1, dx2, dx3, and so on, where the dxi is the determinant of a matrix A, where the ith column is replaced by the column matrix B. After that, we divide each of these determinants by D to find the value of the corresponding variables. x1 equals to dx1 divided by D, x2 equals to dx2 divided by D, and so on. Note that the system of equations has a unique solution only when D is not equal to 0.
Moving on to the example of Kramer's rule of 2 by 2 equations. So the question here is that solve the following system of 2 by 2 equations: x plus y equals to 5 and 2x minus 3y equals to -4. The given system can be written in the matrix form AX equals to B. A equals to the coefficient matrix or the square matrix. But for that, I need to write out the X and Y on top of the square matrix so it'd be easier for you to understand. So A equals to 1 and 2 because the coefficient of X is X and 2X, which will be 2. And the coefficient of y is 1 and -3y, which will be -3. And for the x, which is the column with the variables, so x equals to x and y, and b is the column with constant. So b is filled with 5 and -4. So the next thing is that we need to find the determinants of d, dx, and dy. Starting off with D. D equals to the determinant of A. So 1 is lined up with -3, which will make it 1 times -3 minus to 1 times 2. So 1 times -3 minus to 1 times 2 equals to -3 minus 2 equals to -5. So D equals to -5. For dx, if you want to find dx, we need to replace the coefficient of x and replace it with the number in b form, which is 5 and -4. So dx equals to 5 -4, 1 -3 equals to -15 plus 4 equals to -11. So dx equals to -11. Same goes for dy. If we want to look for dy, we have to replace the coefficient of y and replace it with the number in b form. which will be dy equals to the square matrix of 1, 2, and 5, negative 4, equals to negative 4 minus 10, equals to negative 14. So dy is negative 14. After that, by Kramer's rule for two equations, we need to find the x and y. So x equals to dx, which is negative 11, divided by 5, which is negative 5, equals to 11 divided by 5. So x is 11 by 5, divided by 5. And for the y equals to dy divided by d equals to negative 14 divided by negative 5, because dy is negative 14 and d is negative 5, equals to 14 divided by 5. The solution is of the given system is x equals to 11 divided by 5 and y equals to 14 divided by 5. The example for Kramer's rule of 3 by 3 is solve the following system of three equations in three variables using Kramer's rule. X plus y plus z equals to 2, 2x plus y plus 3z equals to 9, and x negative 3 minus 3 plus z equals to 10. The given system can be written in the matrix form ax equals to b, where A, remember that A is the coefficient matrix. So inside the matrix of 3 by 3, there's coefficient of x, coefficient of y, and coefficient of z. So coefficient of x consists 1, 2, 1, which is x, 2x, and x. The coefficient of y consists 1, 1, and negative 3, which is y, y, and negative 3y. And the coefficient of z is z, which is 1, positive 3z, which is 3, and z, which is 1. So x consists the variables of the equation, which is x, y, and z. And b consists the column with constant, or the stuff that's across the equal sign, which is 2, 9, and 10. So b equals to 2, 9, and 10. After that, we will compute the determinant of d, dx, dy, and dz. Let us start with d. D equals to determinant of A equals to the 3 by 3 matrix of A. 1, it would be 1 times 1 is 1, minus 3 times negative 3 is positive 9. So it would be 1 times 1 plus 9. 2 times 1 is 2, minus the 3 times 1 is negative 3. So it would be 1 times 2 minus 3, plus 1, 2 times negative 3 is negative 6, minus 2, 1 times 1 is negative 1. So it would be 1 times negative 6 minus 1 equals to 10 times 1 minus 2, 7 equals to 4. So the d equals to 4. We are going to look for dx. Now, if you want to find dx, we have to replace the coefficient of x and replace it with the number in b form, which are 2, 9, 10. So dx equals to the 3 by 3 square matrix of 2, 9, 10, 1, 1, negative 3, and 1, 3, 1. If we want to look for 2, we have to eliminate all the numbers into rows and column, which will be left with 1 times 1 minus 3 times negative 3, which is 1 times 1 plus 9, minus 2, 1 times 9 minus 30, plus 1 times negative 27 minus 2, 10, equals to 20 plus 21 negative 37 equals to 4. So dx equals to 4. The same goes for dy. If you want to look for dy, we have to replace the coefficient of y with the number in b form, which is 2, 9, and 10. It would be 1 times 9 minus 30, minus 2 times 2 minus 3, plus 1 times 20 minus 2, 9, equals to negative 21 plus 2 plus 11 equals to negative 8. So dy is negative 8. The same goes for dz. We have to replace the coefficient of z with the number in b. So it'd be 1 times 10 plus 27 minus 1 times 20 minus 9 plus 2 times negative 6 minus 11 equals to 37 minus 11 minus 14 equals to 12. Now, we apply the formulas to look for the x, y, and z. X equals to dx divided by d, which is dx is 4 and d is 4. So 4 divided by 4 equals to 1. And for y equals to dy divided by d. So negative 8 divided by 4 equals to negative 2. Z equals to dz divided by d, which is 12 divided by 4 equals to 3. So the solution of the given system is x equals to 1, y equals to negative 2, and z equals to 3.
The inverse of a matrix is another matrix that when multiplied by a given matrix gives a multiplicative identity. Matrix inversion is used to find solutions to linear equations by the matrix inversion method. The inverse of a square matrix A is the matrix A to the power of negative 1 as follows. A times inverse A equals to I, where I is the identity matrix. A square matrix A has an inverse if the determinant of A equals to 0. The so-called invertible matrix theorem is a major result of linear algebra and relates the existence of inverse matrices to many other equivalent properties. A matrix that has an inverse is said to be non-singular or invertible. For a 2 times 2 matrix, A equals to the matrix of A, B, C, D. The matrix inverse is A to the power of negative 1 equals to 1 per determinant A times the matrix of D, negative B, negative C, and A. Also equals to 1 per A times D minus B times C times the matrix of D times D, negative B, negative C, and A. For a 3 times 3 matrix, A equals to A11, A12, A13, A21, A22, A23, A31, A32, and A33, where the matrix inverse is 1 per determinant A and the matrix as shown in the slide. Next is the example question of inverse matrix. The question is find the inverse matrix of matrix A where the matrix is negative 3, 4, 2, 5. The solution of this question is the given matrix is A equals to the matrix of negative 3, 4, 2, and 5. The formula to calculate the matrix inverse of A is the inverse matrix A equals to 1 per determinant A times the matrix of D minus B minus C and A. Also equals to 1 per A times D minus BC times the matrix of D, negative B, negative C, A. So the inverse of A equals to 1 per negative 3 times 5 minus 4 times 2 times the matrix of 5, negative 4, negative 2, negative 3. It also means 1 per negative 15 minus 8 times the matrix of 5, negative 4, negative 2, negative 3. So the inverse matrix of A is negative 1 per 23 times the matrix of 5, negative 4, negative 2, and negative 3. For number 1, A equals to the matrix of 3 times 3 arranged matrix, which is negative 5, 2, 0, 7, negative 3, 4, negative 1, 3, and 2. And C equals to the also 3 times 3 arranged matrix of 0, negative 1, 8, 6, negative 14, 2, 9, 5, and 1. Find the matrix of A plus C. So A plus C is equals to the 3 times 3 arranged matrix of negative 5, 2, 0, 7, negative 3, 4, negative 1, 3, 2, plus the 3 times 3 matrix of 0, negative 1, 8, 6, negative 14, 2, 9, 5, 1. So A plus C equals to The first one is negative 5 plus 0, and then 2 minus 1, and then 0 plus 8, and then 7 plus 6, and then minus 3 minus 4, and then 4 plus 2, and then negative 1 plus 9, and then 3 plus 5, and then 2 plus 1. So A plus C equals to the matrix 3 times 3 arranged matrix of negative 5, 1, 8, 13, negative 17, 6, 8, 8, and 3. Next is number 2. Matrix A equals to 2 times 2 arranged matrix of 1, 7, 2, and 4. And B is also arranged 2 times 2, which is 3, 3, 5, and 2. Find matrix C, which equals to A times B. So A times B is 1, 7, 2, 4 times 3, 3, 5, 2 equals to A1 times B1, A1 times B2, A2 times B1, and A2 times B2. So 1, 7, 2, 4 times 3, 3, 5, 2 equals to, the first one is 1 times 3 plus 7 times 5, and then 1 times 3 plus 7 times 2, and then 2 times 3 plus 4 times 5. And the last one is 2 times 3 plus 4 times 2. So now we can complete the product of the matrix C, which is equals to the 2 times 2 arranged matrix of 38, 17, 26, and 14. Next is number 3. Matrix M is equals to 9, 8, 7, 4, 3, 2, which is arranged in the order of 2 times 3. Find the transpose of matrix M. The given matrix has the order of 2 times 3. So the transpose of a matrix is given by interchanging the rows and the columns. So the transpose of matrix M is m to the power of t equals to the order of 3 times 2, where 9, 4, 8, 3, 7, and 2. Number 4. Find the determinant of the matrix with of the order 3 times 3, which are 5, 14, 2, negative 8, negative 6, 2, 9, 3, and 4. The determinant is equals to 5, 14, 2, negative 8, negative 6, 2, 9, 3, 4, minus 5, 14, 2, minus 8, minus 6, 2, 9, 3, 4, plus 5, 14, 2, negative 8, negative 6, 2, 9, 3, 4. To find the determinant, we take 5 from the first one times negative 6, 2, 3, 4, which are taken from the blue highlight. And then negative 14 from the yellow highlight times the blue highlight, which are negative 8, 2, 9, 4, plus 2 from the yellow highlight times the blue highlight, which are negative 8, negative 6, 9, and 3. So the determinant is 5 times negative 30 plus negative 14 times negative 50 plus 2 times 30. The determinant is equals to negative 150 plus 700 plus 60, which is equals to 610. So the determinant of the matrix is 610. And number 5, find the inverse of the matrix 2 times 2 order of 4, 2, negative 1, and 5. So the inverse matrix A equals to 1 per determinant of the matrix 4, 2, negative 1, and 5 times 5, negative 2, 1, 4 matrix. So determinant of matrix 4, 2, negative 1, 5 equals to 22. So the inverse of A equals to 1 per 22 times the matrix of 5, negative 2, 1, and 4, which is equals to the matrix of 5 per 22, negative 2 per 22, 1 per 22, 4 per 22, which we can simplify, and so the inverse of the matrix is 5 per 22, negative 1 per 11, 1 per 22, and 2 per 11.